Circular cross-sections. Also known as solids of revolution, circular cross-sections have an area A of x equals pi times f of x squared. This is because the area of a circle is pi r squared, but in this case, our radius is determined by the function f of x. So if I just take some random function here, and I were to rotate it around the x-axis, so if I were to take this thing and rotate it around the x-axis, I would get a circular cross-section. So we can see that by picking any random point on the curve, and then when we rotate it, we'll get something that looks like this. And so this gives you our circular shape, in which we will get the area of this by using the radius. So this is the coordinate x comma f of x. So then this radius is given by f of x. And we saw this when we revolved this shape earlier. And so the cross section of this is going to look something like this, which is a circle, where the radius is given by this length here. The region between the graph of f of x equals 2 plus x cosine of x and the x-axis over the interval -2 to 2 is revolved about the x-axis to generate a solid. Determine the volume. So we're going to break this down into a couple steps. Step 1, I do recommend that you graph this in the two-dimensional plane. And if you do that, you'll get something that looks like this. Now before I show you the next steps, I want to show you in 3D what this looks like so you can have an idea. So here's the graph of 2 plus x cosine x. And what we're going to do is we're going to take this graph right here and we're going to spin it about the x-axis. So it's going to come out of the graph and it's going to spin around this like this. So in 3D, what this is going to look like, it's going to look like this. So here's 2 plus x cosine of x. And we're going to go ahead and revolve that around the x-axis. So as we spin it around, it's going to create a new shape. And you can already see the circular cross-sections right here when it's underneath the y-axis. And it's going to spin up and about now. And it's going to create a vase-type shape. And so what we're going to do is we're going to look at the circular cross-sections of this graph. So as I move this back and forth, you can see how the cross-sections are circles. So you can see no matter where it is, the graph will always rotate around these circular sections. So again, if I were to slice this down like this, I would create these circular cross-sections. So this is what the graph looks like in 3D when it's all completed. The way I recommend to show your work on this so you don't kind of get lost is to graph it on your paper and then kind of draw just a quick little circle like this, where this is r and r is equal to f of x. It's also important to note we're integrating with respect to dx. So we're integrating from -2 to 2. So according to our equation, our volume is equal to the integral from -2 to 2, because those are our limits, of pi times f of x squared dx. So our volume then is from -2 to 2. I'm going to factor out the pi. And our function was 2 plus x cosine of x, and then we square that dx. And if this was an easier integral, we would do that by hand, but because it's kind of a difficult one, we're going to use a calculator. So you hit Math 9, and you're going to integrate from -2 to 2 of 2 plus x cosine of x. But we need to make sure we square that. And then dx. And then so we get a number. And then what we need to do is multiply that by pi. and you get 52.428. So this is about 52.428 units cubed. So the volume of this really irregular shape back up here was an exact value of 52.428 units cubed. So on your own, I want you to try to determine the volume of the solid generated by revolving x plus 2y equals 2 about the x-axis on the interval 0 to 2. I also recommend that you integrate with respect to x for this one, which means you're going to need to get y equals something. And so what we're going to do now is we're going to solve it. So the first thing I recommend you do is rewrite it in terms of y. So we have the equation x plus 2y is equal to 2. So then y is equal to 1 minus x over 2. And then what we need to do is we need to graph that on our paper. And then the idea behind this problem is we're going to revolve this around the x-axis. So we're going to pick a point, let's say this one, and then we're going to spin it like this around the x-axis. And so our graph then will keep going like this, and then it'll revolve back to go up like this. And this is going to create our three-dimensional shape. So if I connect these, I didn't draw it perfect, we'll get a shape like this. And the idea is we are revolving around the x-axis. And so what this looks like in 3D is something like this. So here's our graph. And what we're going to do is we're going to spin this around this way. So in 3D, let's look at it. So here's our graph, and now we're going to spin it around. So if we spin it around the x-axis, we get something that's going to look like this. I'll zoom in a little more so we can see it. And it kind of looks like an ice cream cone or a cone with the most pointed part right here. So as you spin around, you're going to get this cone shape. And so if you can see the cross sections right here, which are going to be circular. So if I put the cross section in, you see we get circular cross sections. So again, if you take a cone and cut it up, you get circular cross sections. And so what we're going to do then is we're going to look at the 3D shape, which is over here. And I want you guys to notice that these cross sections create a circle, where the radius is given by this length right here. And our radius is r equals 1 over x minus 2, because our radius is the distance from the x-axis to the function. So now all we have to do is integrate. So you get the integral from 0 to 2 times pi 1 minus x over 2 squared dx. Again, because this was f of x. Now this is something that's easy enough we can do by hand. So then our answer is 2/3 pi units cubed, which is equivalent to 2.093 units cubed. So this is a problem that could be given on a calculator or no calculator section.